Greetings, Professor McKee here with another quick Excel tip your finance professor wishes you knew. In this video, we will learn how to use the NPER function in Excel to find the maturity of an ordinary annuity. In any intro finance class, you will have a unit on annuities, and we professors will always have questions where we give you 4 of the annuity's characteristics and then ask you to find the missing one. If you want to ace those questions, this video is for you. I have prepared a question here asking us for how long it's going to take, how many years, how many periods, to accumulate $1 million, which is asking for effectively the maturity of an annuity because I have a constant payment each period. Now, for any annuity question, including this one, the best practice is to take this verbal description and turn it into actual numbers that we can then do the math on. So N is our first one. That's what we're trying to find. So we'll skip that and come back to it. The interest rate I is our interest rate. That's the 5%, so 0.05. Our present value, that would be basically initial amount in the account. Nothing is told, and that means we have nothing in the account. It's a brand new account. So 0 is what we would put there. The payment is the constant payment every year. I'm putting $6,000 each year into this account, so it's going to be a constant $6,000. And then future value, that's the amount we are trying to accumulate. It's going to be $1 million, so 1 million as the amount for future value. Now, I need to make an adjustment here. Excel thinks there's going to be signs on present value payment and future value. Present value doesn't matter because that's a 0. But payment and future value are both cash flows, and their cash flows are not going in the same direction. 6,000 every year is going into the account, and then 1 million comes back out. So one of these needs to be positive, one needs to be negative. It doesn't really matter which one I pick. I'm going to say 6,000 is going in each year. That's sort of a cash expense for me. And then once I retire, perhaps is what this is for. And once I retire with $1 million, then I'm taking the $1 million out, and that's positive cash. So my advice is kind of think of it from somebody's perspective. In this case, I'm thinking it from Eric's perspective. Now, with all these in, I can go to N, type in equals NPER, and it will tell me what parameters I need. So I need interest rate, that's my 0.05. I need payment, that's my negative 6,000. PV is for present value, that's 0. And then future values in brackets. That means there's a default value. Excel's default value is 0. We don't want 0 though. We want 1 million. So we're going to put in 1 million instead of 0. And then type is if we have something different from an ordinary annuity, but our annuity is ordinary, it's at the end of each period. So there is no need to change that. We leave it alone, hit enter, and we get our number of periods here. So there's 45.7 periods needed to reach 1 million. If we say round up to the nearest whole number, we would say 46 years until we accumulate this 1 million. And that is our answer. Well, you would probably be asked to round to the nearest whole number. Now, if we want to use some better Excel practices, be a little fancier, most importantly, be able to take this file, save it, and reuse it if there's more questions, because there will be, we can go in here, and instead of entering everything directly, we use cell references. So we tell Excel what cell to reference when it is trying to calculate this NPER function. So instead of typing in 0.05 for rate, we instead go to the cell that we put rate into, B7, we put in B7. You can see how this lights up blue. Up here is also blue in our equation up there. And we can click, so payment was B9, so I click on B9, B8, and B10, and I get all of my cells entered into the function. If I hit enter, as you can see, my 45.7 has not changed. I'm still getting that same 46 basically years until I reach the accumulated future value that I want. Now, the reason we do this, well, there's a couple reasons in this case. 1 million is really big. It's really easy to miscount your numbers here when you're just entering them all into this little function. But that's very easy to tell, oh yeah, this is not actually 1 million, or it is 1 million here. And also, we can change things. So let's say I have a new question. The question has different values for this annuity. I just change things here, and then my function automatically updates. It's very clear and obvious to me what values I am assigning to each of the parameters that go into the annuity. Just to demonstrate, let's say we change our interest rate. Instead of the 5%, we have 8%. I'll go here, I change it to 8, and immediately my number of periods will update. It goes down quite a lot actually, and that's because I'm earning more interest every year in this account as I am accumulating towards that 1 million. So 34 years now, 34 and a half roughly, versus the previous amount. It's almost, actually it's more than 10 years that I've saved just by boosting my interest rate by a few percentage points. Now, so with this single function, you can find the maturity for any annuity your professor might throw at you. If you found this video helpful, please comment, like, and/or subscribe so that other students can find it too. Happy studying.